I simply started and I didn't check that I didn't share my screen.
It's okay, sir.
Okay. Now, if I take a point charge here, or let's take point here, it having charge Q, and somewhere there is a test charge, means Q naught at any position. So due to that, there is a force of either attraction or repulsion. So let's assume there is a force F here. So electric field at this any point that where test charge here acting. So E equals to F by Q naught. So what was F?
Force of attraction or repulsion.
Yeah, and what's the formula for that?
1 minute, sir.
Yesterday we wrote, come on, recall.
Exactly 1 by 4 pi.
Epsilon naught.
1 minute. I just forgot it.
It's okay. See, remember like our gravitational force. What was the gravitational force? G m1 m2 by r square, right?
Yeah.
Similar. K q1 q2 by r square. Now what is q1? It's q. What is q2? Q naught
Okay.
by r square. Let's take here r distance. Now divided by q naught. So q naught cancel. So what is electric field formula? 1 by 4 pi epsilon naught q by r square.
Okay, sir.
Now, likewise, if we have so many point charges here, then we can just have what? Superposition of electric field. So it will be summation of this one equals to E1 plus E2 plus E3 plus so on.
Okay.
So this is called superposition. Similar way what we did for force, same thing here, ditto same thing. Superposition of electric field. Now next is your electric force. We saw the electric line of force, electric line. Lines of force. Okay, by the way, this is okay, but what will be unit for this one? Can you tell me unit? Can you just make a unit for this? I know it's unknown for you, but still I want you to make a unit from the remaining formula, from the formula. What will be unit?
Volt.
No, just see the formula. From formula, I want you to make unit. What is the formula for E?
F by Q naught.
F by Q naught. So what is the unit of F? What's the unit of F?
Newton.
Exactly. So Newton per.
SI unit for Q naught.
Yeah, what is it? SI unit of Q? SI unit of charge?
Coulomb.
Coulomb. Very good. So now combine the unit. Newton per Coulomb.
Okay.
Now, as the force is vector quantity and charge is scalar quantity, so division of this one will give you vector quantity. So this electric field is.
So I have a doubt.
Bolo.
When we divide any vector quantity with scalar quantity, the result will always be vector, or it can also be scalar.
It will be always be vector.
Okay.
Now, electric lines of force. Now, electric lines. Now, when we talk of electric lines, it is just like if you see, can you see the lines around any magnet? If I say magnet is having some attractive force, but can we see the thing actually?
No.
We can't see. Same way, can we see if I'm standing near, like if you have been to railway station, they have written that 25,000 volts, stay away, right? Warning they have written there.
Yeah. Yes, sir.
So now, can we see the till what is the range for that? We cannot see range. That's why they have given separately some distance, like not exactly the distance, but they have kept a bridge so much far that you will not touch. So these are just an imaginary line. Imaginary line.
So these electric lines of force are imaginary lines.
Yeah. So ditto like your magnetic. These are imaginary lines. If you remember 10th standard, you have one oysters experiment. Like there was a cardboard and he just sprinkled some iron fillings and he placed one magnet and it started making a pattern, right? There was an experiment for you in 10th standard.
Yes, sir, it was there.
Yeah. So in that, what we saw, they are just gathering around it. So with that, we made idea, okay, there are magnetic field lines around the magnet. So likewise, this that is also imaginary line. This is also imaginary lines, of course. Now, one assumption here, whenever it is positive charge, so it is radially outward. When it is negative charge, it is
It's inward.
radially, yeah, inward. Okay, so then we have two charges. Now combine this and tell me, how will you draw this?
No idea, sir, exactly.
This, see, get idea from here.
Okay, so in the positive charge, it's going outwards, and in a negative charge, it's coming inwards. So
Exactly. So it will be attractive or repulsive?
attractive.
Yes. So it is going outward, that means this is going inward. This is going outward, that means this is going inward. So this is the main reason why an opposite charge attract and like charge repels,
Different.
or same charge repel. This is the reason.
Okay, sir.
Now this was positive and negative too.
Yes.
So if I take two negative, then draw electric lines of force for this one.
They will repel
So how will you draw this one?
outwards.
Yeah. So for negative one, inward, and positive one, outward. So they will be forming outward here. This is also outward. They will move here. Repel.
Yeah.
And this one,
It's inward.
yeah. So clear about lines of force?
Yes, sir.
Okay. So next thing we can, let me just erase this much part is, so let's write some properties of this one. We can make some points up from these diagrams.
Okay, sir.
So first thing what we concluded, they are outward and inward. Who is outward and who is inward?
Positive is outward and negative is inward.
Yeah, so they are moving radially outward and negative is radially inward. Now, next thing, what we saw, when these two opposite lines are there, then what will happen?
Attraction will happen, so they both will attract, and when there's the same thing, they will repel.
Ripple. So 2 points over.
Yes, sir.
This was 1 point. So this was second point. So let's see third point here. Then third, what we can say, um, like magnetic force only we can make here. Okay, so this number of lines. So if you remember magnet, north and south, right? So we say it's originating from north, terminating in south, right?
Yes, sir.
Emerging from north, merging in the south. So similar way we can write here also. Number of lines originate or terminate on charge, which is proportional to magnitude of charge. Now, what does it mean? What does this statement means?
It means like the number of lines which terminate or originate based on charge is directly proportional to the magnitude of charge.
Okay, so this means like more the lines, more the strength.
Yes.
Like if we go back to our magnet, I'm just comparing with magnet because that thing you know.
Okay, sir.
So north and south. So if I say there are so many lines of here, so in poles it is stronger than at some other point. That's what we say.
Yes,
At
sir.
poles, a magnetic field is stronger. So same way, if we consider here also at the charge, this will be higher as compared to other places.
Okay, sir.
So Q1
So
is
as the
proportional to
magnitude of charge increases, the number of lines also increase.
exactly. So charge is proportional to N. So Q1 by Q2. So we can say N1 by N2. They are directly proportional. Okay, so let's come. Next one from magnetic field, what we can say, uh, magnetic field lines never intersect.
Yes,
Why
sir.
they don't? Why they don't intersect? Do you remember that? Why they don't intersect?
Because if two or more lines intersect each other, it means that the magnetic fields has two directions at same point.
Exactly, and which is not possible. We
Exactly.
cannot have two directions like the same. The same we can write here. So two electric field lines or electric lines can never intersect. Now, fifth one, what we wrote before, some originating from north and south, like that same way. So it begins, in this case, it begins from positive charge and
Merges at
ends
negative.
exactly ends on negative charge. And here, one very, very important point, which is not about magnetic field. Because magnetic field, they are closed loop. If you have observed that it's moving north and south, it's from closed loop. But
Yes.
here, they doesn't form closed loop. Okay. So difference between this is only the main point, major point. So I'll write fully magnetic field forms closed loop. But electric field lines do not make closed loop.
Okay, sir.
So apart from magnetic fields property similarities, now some points we will write which is not about magnetic field now. It's
Okay.
its sole property of only electric field. So first thing, let me draw first. Okay. So electric field which are closer together are stronger. They are far means they are weak.
Okay, sir.
Now last point we can say, okay, if this is the point of this is the line here, okay, let me draw it separately. So if I say if this is the surface, he is producing charge or electric field. So this will always be perpendicular. I'm not drawing fully. If it is plus here, no, plus means it's going outward, no? That means this will have negative charge. This is a wall, it's having negative charge. This is a charge positive.
Okay.
So this is having positive charge, means it is moving outward. So let's assume these are negative particle of wall. Now thing is that either it is this is positive, negative. So let's say originating or terminating, whatever. It
Okay.
always has at right angle. This
Like
point will be right angle.
it's always perpendicular to the point.
Yes. So this 7 properties clear.
Yes, sir.
Check once again all these properties because we will use in while solving.
Like, so questions will be based on the formulas mostly.
We haven't derived any formula yet, just one formula we
Not
saw.
this one, sir. I meant about this electric field.
Yeah. Then we need to some manipulate few formulas. Same base formula only. These are the base formula.
Okay.
So we need to manipulate little bit as per the requirement.
Okay, sir.
Okay. And I'm not going to derive whole derivation all that because it will take so much time. Anyhow, you are going to study for your board exams, right? For that,
Yes, sir.
here my focus is JEE questions only. So I'll spend more time for JEE questions.
Okay, sir.
Okay, so this one, let's see first charge distribution.
Okay.
So we saw already, we saw, right? Continuous charge distribution. Yes, this we already saw that. So we'll see some various way, like we saw just general idea. Excuse me. So electric field due to various charge distribution. So first one, if there is a charge here and we are taking a point P somewhere, So due to that, there will be an electric field on suppose this direction, which is separated by distance x. So electric field due to a point P. Electric field and isolated point. This will be equals to E equals to K Q by what is distance here? R. Instead of R, we'll write here x square.
X.
X square. Because our formula is KQ by R square. Now, instead of this point, if I take a circular ring or circular disc or whatever, like circular form. So let's see both things one by one. So this formula is required for solving, but even this is common formula. You already same formula we are using.
Yes, sir.
Just we have separated like distance R. Instead of R, here we have X. Now for a circular ring. With uniform distribution. So let me draw a ring here. Center here. This is sub point P. So same way electric field E. Now this, I'm sorry, this distance is, let's take same X. Okay, so if I consider one small ring for this, if I consider small charge here, it will be small q.
Okay.
And the radius of this ring be R. Okay, if I consider one small ring here or a small portion of it, so this can be just integrated over all the surface. So first, when we studied charge properties, we said charge can be added. So if we take total charge of this ring, let it be capital Q. And on single small unit, small distance, small charge, so it will be, we will take as small q, dr, dx, or whatever, small thing. So here total electric field, K, capital Q, into X. Now how it came X, that is different case. Okay, so I'll just tell you one idea for this one because it will take so much time to drive, but I'll show you here. But
Okay,
where is it? Huh? So this is your R distance. And this is your X distance.
yes.
In the ring. So obviously radius will be R only. Anywhere in the ring, radius will be R from the center. And this point P will be same distance X from anywhere from the circle.
Yes.
So if I'm taking from here or here or here or this place, any place, point this one, or let's take from so this point, how to find this length?
In general, in maths, we use Pythagoras theorem.
Exactly. Tell me. Just tell me orally. I don't want you to solve here. Just tell me orally.
R square plus P square is equal to the length.
R square plus, it is X. R square plus X square.
Oh,
Which
sorry.
is, yeah,
R square plus X square is equal to the length.
exactly. So under root r square plus x square. We found length.
Yeah.
Now this
So
point,
basically, you give the values in the exam, sir, or like any two values, or
what do you mean?
so
I get
if
your point.
if there's a question in mains about this, so they basically give the 2 point like two values, right? R and X.
Yeah, but they will not say these are these x. We need to understand what they're asking.
Yeah, sir. I was just asking
Almost,
to give the
yeah,
value.
yeah. Obviously, they have to give. Otherwise, how we will find? Okay, here we need to just integrate and differentiate all that. X square by 3 by 2. Now, generally, this point O, let's take here a point O. O and P, that is X. X distance is very, very small generally.
Okay.
It's somewhere, anywhere. It can be so infinite or very, very small. It
Okay.
can be both cases. So let's assume this is at very, very far distance. Okay, so if X is very, very far distance, then as compared to X, R is very, very small.
Yeah. Like X is
Now,
infinitely big.
yeah. So R is very, very small because R is fixed. X can be varied. Our
Yeah.
ring is fixed. We cannot increase ring now.
Yes, sir.
So I can substitute, I just can eliminate this R value and we can say here K Q X by X square 3 by 2. So 3 square. So K Q by X square. That is our E value for this condition.
Okay, sir.
Anyhow, for exam, we will keep only this formula. Depends upon given condition, we will see that.
Okay, sir.
We will not take infinitely small value here or infinitely big value. We will not do anything. We'll just substitute values. Let it be very small, let it be very large. We'll keep it. But say it won't make much difference because it will be in millimeters and this will be in like meters or centimeters.
Okay, sir.
So if it is this condition, if this is if we got this one, then ring will behave as a point charge, very, very small, because distance itself is very, very large and as compared to r, so it will behave as a what do you say, point charge. Behave as a point charge. Now, ring actually, we are wearing ring, but for us it is not point charge. It's big actually. Are you
Okay.
wearing any ring on your hand?
No, sir.
Have you seen your father or mother?
Yeah, I have, sir.
So if you observe that the ring is actually not so big, but we cannot say it's very, very small also. Like dot. Dot is a small.
Yeah. It's
So
just like it basically fits the finger.
yeah. So how do we compare a point charge? What is point charge then? I wrote here ring behaves as a point charge, but how can ring be point charge?
Like I didn't get your question exactly, sir.
See what I wrote here, ring behave as a point charge. Point charge means just point, a very small charge, right? Minute charge. So how can ring be like that? Or if I say point distance, how can we say that point distance? Okay, I'll say that. This things comparison depends upon with what we are comparing.
The distance.
Yeah, just now I gave you example of this ring that we are wearing. Okay, if I
Yeah.
compare with us, yeah, it's big. Now, if we are comparing with elephant, then
It's really small.
it's small, just small thing. Now, same thing if we are comparing with some dinosaur,
It's more tiny.
more tiny. Now with Earth, a tiniest thing, right?
Yes,
So
sir.
it depends with what we are comparing. Now, as we see our screen, we have written so many things, but can you observe point? I kept one point somewhere. Just now I kept.
No, I
See
can't.
here. See here.
Oh,
Right? So
yes.
that depends with what we are comparing. Because whole screen is big as compared
That,
to the point.
yeah.
But if I compare with my laptop, its screen is small. So now, next thing. So you understood, right? Point charge means how to understand point.
Yes, sir.
Super. Next one, third one. Which one we wrote? Circular ring. Okay. Then here, circular disc. Now, ring was hollow, disc is not hollow. Disc of radius r. So this is the point here. Let's take r. This is your x and electric field. P, electric field. And this is r. X. Now it is uniformly distributed with surface charge density. So surface charge density. What was surface charge density? Charge per what? Can you hear me?
Hello.
Yeah, can you hear me?
Yes, sir. Could you repeat the question, please?
What is surface charge density?
Q by A.
Q by A. Then what was linear? Linear charge density?
Q by L.
And volume?
The form.
Yeah, volume charge density? Same, Q by V.
Oh, yeah. Sorry, sir.
Ah, it's okay. Just whatever it is, charge per unit, that thing. No need to
Okay, sir.
remember, memorize anything.
Oh,
Just
sorry. The same dq by dl, dq by da, dq by dv.
exactly. Simple. So right now we're considering charge per unit, this one. Okay. So E equals to 2. I'll just write direct formula here. This is charge Q. 2k q by r square 1 minus x by r square plus x square. And this derivation is not there for your, I think, so board exam also. Deleted portion. I'm not
But we
sure, but
use the formula.
yeah, we will use this. So charge per unit length we can write here. Then we can introduce here this one. Now K also we can write 1 by 4 pi epsilon naught. And area also we can write here pi r square and all that. So sigma we can do that because area is what? Pi r square. So here 1 by 4 pi epsilon naught. Pi and r square will become area. So charge per area will give you sigma. and 4 and 2 will get cancelled. So sigma 2 epsilon naught 1 minus x by r square plus x square. Charge per area. Area is pi r square. And what is K? 1 by 4 pi epsilon naught. So pi I am taking and R is already there. Got it?
Yes, sir.
So if we collect all these formulas, then we can do all these J equations. But in the J equation, it will be mixed actually with
Like
some
all the
dipole.
formulas. Like in one
Yeah,
question, we use two formulas or something.
exactly. And dipoles also we have to include, then electric potential also we have to include sometimes.
Oh,
So like actually see questions of JEE are like not so tough, but what they do, they just have mixed concepts.
so they twist the questions to confuse us.
Exactly. So if you get scared, you're done. So instead of getting scared, just think, okay, what is this given, and what is the like answer given? Like what are the options given? So from option, always choose the correct like opportunity to find a formula.
Okay, sir.
So whenever I'm solving some question, I always tell my student like always keep option in mind.
Okay, sir.
So let's write this was number 3. So let's write fourth one. So if it is some infinite sheet of uniformly distributed charge, UDC, with charge density. So if I take some infinitely charge, sigma by 2 epsilon naught.
So this is simple. So only this much is the formula.
This much.
Okay, sir.
Because here only we got it, right? Sigma by 2 epsilon naught.
Yes, sir.
Similar way.
Okay, sir.
Now fifth one is much simpler than that. Here we will take linear charge density here because we are going to do line. This is x distance at point P. Now let's take this as a alpha x distance. This is beta. So electric field, it is at angle. So we will distribute in two components, EY and EX. One
Okay.
horizontal, vertical component. So let's give a heading according to that. Finite length of charge with linear charge density lambda. So if I consider x axis, so there will be cos component, not cos component, sine component.
Okay.
Up, this will be cos, and this will be opposite direction. So y will be opposite direction. To y direction will be one here and one here. X will be, sorry, beta will be upside and alpha will be here.
Okay.
So Ex equals to K lambda by X sine alpha plus sine beta. Then Ey equals to K lambda by X cos alpha minus cos beta. So generally a special case, alpha equals to beta equals to 90 degree or pi by 2. So pi by 2 means whatever this angle, it will become like this. It will become vertical like this.
Yeah, perpendicular 90 degrees.
Exactly. It's the special case for this.
Okay, sir.
So next, tomorrow we'll see some numerical based on this one.
Okay, sir.
And so how does the motion of electrons in electric field? What will happen with that?
Okay, sir.
Okay. So you understood today's class, all this,
Yes, sir.
how this form, how to remember these formulas and all that,
Yes, sir.
and these properties of EF.
Yes, sir. I remember.
Okay. Okay, then we'll see you on Monday.
So there's no class tomorrow.
Sunday, no classes, only Monday to Friday, Saturday.
Oh, okay, sir.
Sunday is actually test day, but I didn't finish electric field. If I would have finished electric field, then we could have test.
Yeah. So there will be no classes tomorrow.
No class.
Okay, sir. Thank you.
Okay, dear. Bye bye.
Bye.